Hello, welcome to the video. In this section, we're going to be looking at, this lesson, we're looking at section 10.3, where we're going to be looking at two-way tables and probability. So one of the things that they are asking us is how can you construct a two-way table and how can we interpret a two-way table? So for example, let's say kind of similar. So let's say like we were talking about a class going to a concert. And to make a table about this, I believe let's say we broke it up into grades. So let's say like, you had, you know, ninth graders and 10th. So like you had freshman and sophomore. All right. From this concert here, you either were going to attend or you're not going to attend. So if we put some data in here, let's just say that 25 ninth graders attended, let's say 80 10th graders attended, let's say 45 ninth graders did not, and let's say 32 10th graders did. All right. What we would have here is these numbers of 25, 45, 80, and 32. By definition, all of those values are called the joint frequency. All right, so the joint frequency of this data explains that um, it's the sum of the entry of the table. This is the entries of the tables. Okay, so being able to categorize them in a specific way using two different parts. Now, we can interpret this a couple ways. One, we can now determine between the ninth and 10th graders how many did go total and how many of them did not go total. So you could say, for instance, we could figure out how many went to the concert between ninth and 10th graders, which would be 25 plus 80, which is what, 105. We could figure out how many ninth and 10th graders did not attend the concert, which would be 45 plus 32, which would be what, 77. We could also figure out how many ninth graders are in the class. In this case, would be 45 plus 25, which would be 70. And then we'd have another figure out the number of 10th graders in the class, which would be 80 plus 32, which would be 112. All right. So now these values here on the outside, this is called, so these values here on the outside, these are called the marginal frequency. And they're just the sums of the respected rows and columns. All right. And then at the very end, you can figure out what the total number of ninth and 10th graders there are by either adding 70 plus 112 or 105 plus 77. And you should get the same answer of 182. All right. So here it says in another survey similar to the one we just did, talking about the concerts attended. It says 106 juniors and 114 seniors responded. Of those, 42 juniors and 77 seniors plan on attending. Organize these results in a two-way table, then find and interpret the marginal frequency. So we actually have some portions of the marginal frequency because they told us that we have 106 juniors and 114 seniors. So using this table in the same way. So like we can say attending, not attending. So there's juniors, we got seniors, and from here, what we know is we know that there are 106 juniors that responded, and 114 seniors responded. And it says that there are 42 and 77, so 42 juniors plan on attending. So I would put the 42 here, and 77 seniors plan on attending. So with all of this information, we can kind of use this to kind of decode what the rest of this two-way table is supposed to, we're going to fill in. So the fill in stuff is like, all right, so if I know there's 106 juniors and I know 42 attended, I can figure out how many didn't attend by taking 106 subtracted by 42, and that's 64. I could figure out how many seniors did not attend by taking 114 minus 77, which gets us 37. And then from here, I can figure out how many juniors and seniors attended by taking 42 plus 77, which gets us 119. I can figure out how many juniors and seniors did not attend by adding 64 plus 37, which is 101. And then I could find the total juniors and seniors in the class by adding either 119 to 101 or 106 to 114. Either way, you should get the same answer, and that's 220. From these two-way tables, we can get some statistics out of it, all right? The first uh, term up there is joint relative frequency. So joint relative frequency says is a ratio, which is a fraction, of a frequency that is not in the total row or the total column, but with respect to the total number of values or observations or whom responded. Marginal relative frequency is the sum of the joint relative frequency in a row or a column. So you get to pick. And a conditional relative frequency is a ratio of a joint relative frequency to the marginal relative frequency. You can find a conditional relative frequency using row, total, or row columns of two-way tables. All of that seems challenging, but let's look at some examples and hopefully we can kind of simplify them. All right. So here it says using the table from example 1, so about the juniors and seniors. They want you to, let's make a two-way table that shows joint and marginal relative frequency. All right, so in this particular one, so we're going to go, so we got juniors, we got seniors, we had juniors and seniors that attended, and juniors and seniors that did not attend. All right, so let's look at the joint relative frequency. So we're gonna get, they said it's a ratio, and what you're gonna do is you're gonna find the ratio of how many there was in those four joint spots, and they're gonna be divided by the total number. So if you recall, for like this one here, so you got 42 juniors that attended. There are 220 total people that responded between juniors and seniors. So my joint relative frequency for juniors is going to be 42 over 220, which gets you to a ratio of about 0.191. All right, for seniors that attended, so if you recall, it was 77 over 220. That gets to about 0.35. And then over here, this was 64, so it's going to be 64 over 220, which is equal to 0.291. And then here, this one was 37 over 220, which is equal to about 0.168. All right. So all of these things that we just did are with respect to joint relative frequency. To find marginal relative frequency, you're just going to add up the decimals together. So 1.91 plus 0.35 is 0.541. All right. 0.291 plus 0.168 is 0.459. Now remember that these should be close to 1. So when you add those together, do you get 1? Yes, you do. Here it's 0.91 plus 0.291 over here to get 0.482. And then finally 0.35 plus 0.168 is 0.518. Add those together, you should get 1 as well. All right. So now what we have is the marginal relative frequency. And finally, again, using the same example with the juniors and the seniors, they want us to show conditional relative frequency based on row totals. So they tell us that it's row totals, not just columns. All right, so I got my juniors, I got my seniors, and attending, not attending. So now what you're going to do is you are just looking at uh, the four values of attending, not attending between respects to juniors and seniors. So what you're going to do is it's still a ratio, and your numerators for all of these spots are going to come from these decimal values here. So for the juniors, it was 0.191. For showing up, this one was 0.291. This one was 0.35. And this one was 0.168. All right. So now it is now respect to the rows. So the row in this case is, so like this is row 1, this is row 2. So we're going to be using these values here as our denominators, our respective denominators. So 0.482 and 0.518. So, and again, if it was columns, then you would use these ones here. All right. If it was columns, you'd use these one here, but these are rows. So this is rows and rows, columns and columns. All right. So with that being said, this is now going to be 0.9191 divided by 0.482. This is going to be 0.482 as well. On the bottom, this is going to be 0.518, and this is going to be 0.518. And you're going to get a approximate a decimal value here. So this is going to be 0.396. Over to the right, this is going to be 0.604. And this is going to be 0.676, and this is going to be 0.324. All right, so the big question is, what is the relevance of these decimals or these percentages? So for instance, if I were to look at this particular stat, if you were to convert it to percentages, this would be 60.4%. What we then can conclude is, given that a student is a junior here, the conditional relative frequency is that this person is not, or like this person is not attending the concert is about 60.4%. All right. So Given that the student is a junior, the conditional for relative frequency is that the person is not attending the concert about 60.4%. All right. Here we have some tables, and then in this one it says a satellite TV provider surveys customers in 3 cities. The survey asks whether they would recommend the TV provider to a friend. The results given as joint relative frequencies are shown in the two-way table. So they're joint relative frequencies. So they're with respect to the total. Here it says, what is the probability that a randomly selected customer is located in Glendale will recommend the provider? Okay, so they want to know what's the probability of somebody in Glendale saying yes, kind of deal. Well, what you're going to do is this. So 0.29, so about 29% of the people said yes. So in the numerator of this probability, we're going to put in the 0.29. Divided by, we're going to be looking at the total people, uh, total in that's either said yes or no. So this is going to be what? 0.29 plus 0.05, which in this case is going to be, when you add those together and divide, it's going to be equal to 0.853. So, or if you attach percentages to it, it'd be like 85.3%. So the probability of that a randomly selected customer is located in Glendale that will recommend it, it's about 85.3%. All right, here it says, what is the probability that a randomly selected customer will not recommend the provider uh, is located in Long Beach? So, so they say, so the probability of someone not, so it would be like no, and then also they're from Long Beach. All right, so this in the numerator is where it says no in Long Beach is what, 0.04. And then divide it by, so, you could call somebody in Glendale, you could call somebody in Santa Monica, you could call somebody in Long Beach. So what we're going to do is the denominator is going to be the sums of all the no decimals. So that's going to be 0.05 plus 0.03 plus 0.04. If you attach this, if you add those together and divide accordingly, you get about 0.333 or 33.3%. All right, here it says determine whether recommending the provider to a friend and living in Long Beach are independent events. So let's see. So for it to be an independent event, if you recall from the previous lesson, you have to talk about like the probability of A times it by the probability of B. That's independent. If we were looking at a dependent event, it was going to be the probability of A times it by the probability of B with respect to A. So we're going to look at both formulas to see if they're the same or not. All right. So the probability, again now, so the probability of whether recommending the provider to someone in Long Beach. So if we look at the stats here, Long Beach has, Long Beach has stats of 0.32 and 0.04. So here, to find the probability that whether recommending the provider to a friend, it's either going to be 0.32 plus 0.04, which is going to be equal to 0.36. So that's what it would be as an independent event. For it to be a dependent event, which means that it's going to be the probability of somebody that lives in Long Beach and also says yes. So you're going to be looking at it as the people that said yes in Long Beach, which was 0.32, and it's going to be divided by all of the yeses. So the yeses were 0.29, 0.27, and 0.32. So and when you add up those together on the bottom, and then 0.32 divided by the sum of all those, you get 0.36. So since they're about the same, we can say that this is the two events are independent. All right, so finally here, last example says a jogger wants to burn a certain number of calories during his workout. He maps out 3 possible jogging routes before each workout. He randomly selects a route, then determines the number of calories he burned and whether he reached his goal. The table shows his findings. Which route should he use? All right, so here's how you go about doing this. So what you're going to do is you got A, B, and C. So these routes. All right. What you're going to do is you're going to set these up as a ratio of did he meet his goal or not. So A, he met his goal 5, 10, 11 times. So 11 out of, and then you count total. So 5, 10, 15, 16, 17. So 11 out of 17, which gets us to approximate value of 0.647. For part B, it was 5, 10, 11, and then the total was 5, 10, 15. So 11 out of 15, and that's going to be 0.733. Route C, 5, 10, 12 over 5, 10, 15, 16, 17, 18. So that's the total number of times he chose that route, which would be what? 0.667. So then which route should he use? We just picked the one that he had the highest percentage, and in this case is 0.733, which means he should choose route B. And that is being able to look at two-way tables and probability. Hope this helps. Till next time.